Hi, good afternoon. I'm Dave Doucette. I'm the Senior Product Manager for BIG-IP DNS as well as BIG-IQ DNS. I'm responsible for vision, strategy, and roadmap for the product. And with me today, I have Greg.
I'm Greg Robinson. I'm an SE on the SP cable accounts.
All right, so this topic is DNS security. Here's the agenda. We're going to go into an overview. We're going to talk about BIG-IP DNS protections, as well as BIG-IP AFM protections, DNS flexibility with iRules, IP intelligence analysis, and then a summary. If you'd like to ask a question during any part of the presentation, just raise your hand, and because we're recording this, we'll probably use the mic so that we can get your question recorded. So as an overview, I'm using this report done by Network Solutions. It tells about application layer attacks. And as you notice, DNS is the second highest attack protocol out there under HTTP. This actually was done for enterprise customers. However, when you switch to SP, then DNS actually becomes the highest. It also talks about traditional DDoS mitigation. And as you can see, the highest uses ACLs. And the reason I have it in red is because how good are ACLs generally in blocking DNS attacks? They're not, right? So second is firewalling, which is also not that great of a solution, because generally in your firewall, you're going to have your DNS server as a source. The destination is going to be anything protocol 53 allow, right? But what's most surprising is the third, and that is they do nothing at all. So there are different attack types. There's volumetric, there's protocol, and malformed, and we'll go through next with the top 10 DNS attacks. How many of you have your company been under a DNS attack? Interesting. You don't know? You probably have and just don't know it then, right? No. So how many of these attacks are you guys familiar with? Any? A few? Yeah? Okay, well that's okay because we're going to go through most of these here. We're going to start with a phantom domain attack. What this attack is the malicious entity is going to set up some domains that they're purposefully not going to answer to. So what does that do? They send the attack to it, and it just sits there and does nothing. So what is that? What kind of problem does that cause? Keeps the session open, right? So you only have so large of a buffer. When that buffer fills up, what happens? You're not answering legitimate queries, and that's exactly what this attack is designed to do. How do we mitigate it with BIG-IP? Well, we actually allow you to set that timeout, so we don't let them sit there and hold that connection open forever, and it can be as small as you like. There's also a QPS, so if they're continually doing it, you're seeing a large volume of these requests, so it's volumetric rather than a lockup type attack. We can actually control the queries per second. We're allowing them to actually send at the BIG-IP DNS. This can be done by an iRule, or if you have AFM, AFM has it productized in the product. The next one is an NX domain. What this is an NX domain means it's non-existent. So the attack is a flood of attacks, and it's for zones and records that just don't exist. And so the object of this is to fill up the buffer again and try to stop the DNS server from answering to legitimate queries. So for NX domain attacks, we want to find out the identity of the IP address, and we want to take some mitigation with that. So like we could do the query rate limiting, or we can blacklist the IP address. But what What's wrong with blacklisting an IP address? Well, that's one, but generally a DNS attack is going to be spoofed because you don't want them to know where you're coming from. So anytime we do stuff with blacklisting, it's generally not a permanent thing. You'll do it for a short period of time. Generally, when the attacker finds out or figures out that they're blacklisted, they'll go ahead and give up. We do, and we'll get to that. Mm-hmm. Then the random subdomain attack. So this is one where they're actually going after a zone that you own. So you're expecting stuff from, like, say, f5.com. But what they do is they put a random string in front of it. And so what that does is it makes you think that you do own that record. So you're continue spinning, using your resources to find an answer for it. Excuse me, and you don't. So it ends up being probably an NX domain. But by that time, you may have used up your resources, and again, you can't answer legitimate queries. And we actually wrote an iRules specifically for this type of attack and how to mitigate it. And you can find it on Dev Central. So a lockup domain attack. This is any kind of attack that it just wants you to take and use all your resources. We've talked about a couple already, but these can be established TCP. How many of you have a listener with UDP and TCP? Yeah, you really have to nowadays, right? Because there are things that do run over TCP. Does anybody know some of the stuff that runs over TCP? What's that? DNS Sec can grow to be large enough to use TCP, yep. Exactly, that's the big one, zone transfers, because if you've got large zones, you don't want that going over UDP, right? All right, so with the lockup domains, it's always easiest to answer. We always want to look for an answer first because, especially with our platform, we answer faster than we do anything else, and it takes less resources for us to go ahead and answer. So we have a few things that we can look at, whether it be protocol validation, make sure it's not a actual malformed packet, or we can do connection timeouts. We can do query. I just lost it. Rate limiting. Sorry. So then reflection attacks. So this one is always spoofed. You want to spoof the actual target. You want to spoof their address, and then you want to go to these different, they can be open resolvers or bots or whatever it may be, and your goal is that they're responding back to your target. A very famous reflection attack happened a few years ago to a company called Spamhaus. They had blacklisted a site, and they weren't happy with it, so they launched an attack and ended up being about 30 gigs worth of DNS traffic. So not only did it take down Spamhaus, but it took down most of Europe as well. The way they mitigated it was using IP Anycast. They hired out Cloudflare and were able to spread the load until it was over. What's temporary? Yeah, you continue. Amplification attack. So we had talked a little bit about this before. It's where you actually you probe and try to find a large response, whether it be DNSSEC, because they're obviously a lot larger than the request, or stuff like you could even try to do a zone transfer if it's not locked down, or you could ask for an any record. You know what an any record returns? Every record that it owns. So you look for big responses and then aim that at the place you want to attack. So the way we mitigate this is actually, by default, we drop all unsolicited replies. Not only that, we also allow you to lock down the type of records that you will respond with. If you don't want to respond with any, you can turn that off, and if an any request comes in, we drop it automatically. DNS tunneling attacks. So this is more of an attack that we see on the SP side, but it also, if you're hosting any kind of internet, whether you're sitting at the airport and you don't want to go use, what is the one they always use? They have go hotspot or whatever, and it's quite pricey, especially for what you get. But there is a way to get around that. If you don't want to pay for it, you use tunneling, and you just find an endpoint, basically a VPN, and you run all your traffic through port 53. And generally, because we saw in one of the earlier slides, firewalls don't block anything on 53. So they let all the traffic go through. So some mitigations that we use for this is RPZ. Is anybody familiar with RPZ? DNS firewall. That actually has a list of malicious zones and entities, and it does include some of these VPN endpoints that you can use for tunneling. We also have a pretty sophisticated iRule that does this as well. So malformed package attacks. With a malformed packet attack, they want you to think about it. They want, again, you use up your resources so that you stop responding. And fortunately, this is the HUD filter, the DNS HUD filter. And what this is this is how we process a DNS packet, a DNS query. And it looks a lot like the DNS profile, right? You've all seen the DNS profile, and it has little checkboxes for everything. Well, these are all the engines you can turn on and off, and it's also the order in which things are processed. So when a request comes in, first thing it does is hit protocol validation. And the way we do protocol validation is we look at that packet, and we determine if we can give it an answer. If we can't find an answer for it, we drop it immediately. If the packet's malformed or it's something that we're not supporting, we drop it right away. And then it comes to iRules, DNS Sec, GSLB, DNS Express. So if you have GSLB set up with DNS Express and you're using both, if it finds a WIP first, it'll answer it. If it doesn't, it'll go to DNS Express. If it gets an answer, it answers it. If not, it goes to the cache and so forth. And the last thing it can do is drop to bind, and then bind will do any kind of recursion if you have recursion set and you allow it to return to bind. So cache poisoning attacks. So this is one where I'm trying to force an answer into the cache and have it respond with that. And generally, a prime example would be a banking institution. So I'm sending a request to the bank's DNS server, and then I'm responding back with an address that's mine. And the reason I'm going to do that is because I want the next person that's trying to go to one of their web entities, logging for a banking or whatever, and I'm going to have a site set up just like that so that they go ahead and give me their credentials. So we use DNS Sec to mitigate this. DNS Sec doesn't encrypt the packet, and actually I didn't have this in my last session because this can also be used as an attack because of the size of the answers. But it also brings up a good point with DNS over TLS. Has anybody heard of that? I believe that this DNS Sec is actually going to be replaced by DNS over TLS. It actually has a lot of benefits. One is the validation. And my validation slide isn't there. DNS Sec is only good if it's validated. And to validate it, it's like 15 steps. So it's very resource intensive. And if you don't validate, it does you no good anyways. So some of the protections we have is DNS Express. So like I said earlier, the best way to mitigate a DNS DDoS attack is simply by having the performance available to mitigate it, just to make it through the attack. One way we do this is through DNS Express. With DNS Express, we have a master server, a hidden master, and this can be pretty much anything. It can be info blocks, it can be bind, it can be AD, as long as it'll do a regular zone transfer. The first time the zone comes through, it comes through the full zone. It's an AXFR. But then any changes that are made are pushed through as just the changes. iXFR will go through and update the database. Not only then can we perform way better than anything out there, but we also then protect the hidden master because we are the front end. No clients actually come, no queries actually come to the back end hidden masters. Yes? Yes, yes. Yeah, so we do have bind on box. And if you use Zone Runner to build your zones there and records there, you definitely want to put DNS Express in front of it because bind is not very performant at all. I'm sorry, what? Mm-hmm. Yeah, you have to configure it. So it's actually, you use a loopback address, and then you put the zones that you want to serve with DNS Express. You configure them in DNS Express, but you can do it on box. And bind is actually enabled by default, which is one of the things we're looking at changing. Because if you're not going to use bind, it's best that you turn it off. It's open source. It's non-performant. It's open source, so it gets vulnerabilities. If there's vulnerabilities, you have to patch it, and it's just better to not use bind at all. But if you do use bind, best practice is to front end it with DNS Express, even if it's on the same box. Yes. That should be about it. Yeah, and the only, the thing about DNS Express is it's a single database. It's in memory, so it's a little different than like a bind or something where you have multiple databases you're looking at. And actually, I was in Montreal a couple weeks ago at the DNS Symposium, and had the creator of bind there, the author of bind. We had Cricket Lou and some other folks, and one of the people that came up and talked to us said, I wish I would have never created views. It's the worst thing I could have ever done to DNS. So some people use it and like it. Some people would rather not. So yeah, and because there's only one database, you can't, the views internal, external, you can't do it on the same box. You actually have to, you can't just create one listener for the inside and one for external. You have to use two separate boxes. We do, however, allow views for WIPs and GSLB. You can use topology records in order to create, a view. So we also have this feature. This works with DNS Express. It's a checkbox, and what it does is it short circuits that HUD filter and goes straight to DNS Express, and it doubles the capacity. Now, there are a few things you got to worry about with that, though, is you can't GSLB. It can't be used with GSLB. You can't use iRules with it. It's one of those things where you want to use it when you're actually under attack. Not a good thing probably to have on a normal day-to-day basis. So the protocol validation, like I had mentioned before, is something that's right in front of the HUD filter and blocks the malformed packets. But a neat feature on that is we do actually have hardware acceleration for it. Currently on the B2250, you can do the validation in hardware and get up to 7 times the speed. And then you have also no hit on the CPU or any other resources. Now this is something we're planning on supporting in other hardware. Anything with a FPGA, really, we should be able to do this on. So coming up, we'll probably do the I series and 4450s and that. Of course, you can't put it to hardware if you're using a virtual edition, as there's no FPGA. So here's DNS Sec. We make it a very simple process. When we were designing DNS Sec for Big IP, GTM at the time, we were looking at Linux and how to configure it in Linux and how you do the rollovers, and it's quite a task. It's definitely time consuming, and it's not very straightforward. And then you also have to monitor it, and you have to get your keys up to the registrar and all that kind of stuff. So we've made it very simple, and it's basically a 3-step process. You create a key signing key, a zone signing key, and then assign that to the zone you want to protect. And you can do the automatic rollovers, so that stuff's all taken care of for you. But one of the things that Big IP was a first for was generally bind boxes, everything, all the zones are static. And so they could statically sign a zone. Unfortunately, we didn't have DNS Express at the time. We just had GSLB, GTM. And the problem with that is we had no static zone. And actually, we don't even know the answer for the WIP until it does its little algorithm and gives you the best answer back. And the answer will change depending on the source of the question, or performance, or round trip time. So we are one of the first companies that actually were able to do dynamic signing. So we sign on the fly when it's used with WIPs. So here's DNS Sec validation. This is one reason why more companies don't do the validation, is because it's quite expensive, 15 steps in order to do validation. And this is why I believe that DNS over TLS will actually take over and do the secure DNS stuff. Needs no validation. You're guaranteed that there's nobody in the middle, man in the middle, and then you're also guaranteed that the end user is not being spoofed. There's a common misconception that DNSSEC actually does encrypt the answer, and unfortunately it does not. It sends the answer in clear text and then has a signature that it's signed with. We also have a geo-IP location database that we update on a weekly basis. And this can be not only used for sending customers or clients to the closest data center, but it also can help you to block IP addresses that are from perhaps companies or places that you actually don't want to have a service to. With a geo-IP location database, we go to the state level, but you can actually go through Digital Element and purchase a more granular database that'll get it to city level and beyond. So RPZ, also known as DNS firewall, this is something that I actually contacted Paul Vicky, who wrote this for ISC before we implemented this, and got some best practices. And we were looking at, well, do we partner with people? Do we resell the feeds? And we ended up being agnostic. So we don't actually provide the feed. We don't tell you who to buy from. It's whoever you want to use, and as long as they can do a zone transfer to you, we can support them. We initially tested with SurBL and SpamHouse, but since then we've tested with ThreatStop. Also in a lot of Asian countries, they have to actually use a RPZ feed that comes from the government. You can also create your own if you don't want to purchase. And what the RPZ feed, it's unlike a URL filter or an IPI. It has nothing but malicious sites. It's not categorized, it's just all malicious. So any hit on the feed is going to be malicious. And currently we allow 2 mitigations with this. If it actually does match, we can either send an NX domain saying it doesn't exist, or we can create a walled garden And what that does is that pops back your own site. You can send them to a web server or even create an iRule on the box itself. And it can pop up something like, your laptop's infected. You tried to go to this domain, come CIT to get it cleaned out. And then there's IP Anycast. So this is what we were talking about, how Spamhaus was able to defeat this. IP Anycast should be used. It's really good to be used when you're geographically dispersed, but it also can be used if you're just in one data center. It's just to spread the load across multiple DNS servers. And not only does it do that, but if you are geographically dispersed, we use BGP. We insert the route, and what happens is the internet automatically gets you to your closest DNS server. So iRules, you guys are probably all familiar with iRules. Some people hate them, some people love them. But it gives us a lot of flexibility. If there's something that we don't currently have in the product, zero-day attacks or anything like that, we can actually write an iRule to go ahead and mitigate that. One of the example here is a black hole, and that's probably used the most. You can find that also on DevCentral. But now you can do it on AFM as well. But here's some of the things you can do with it. You can do custom query logging, DNS filtering of any kind, rate limiting, specific query and zone load balancing, honeypot responses. And the nice thing about that is we have DevCentral, which has a lot of resources. The community is huge, and so we can get knowledge from all over the place. And if it's an iRule that is used by a lot of customers or is popular, then we can actually take that and productize it. When we put it in the product, it's generally going to run a little better, a little faster, take up a little less resources than what it would if you had written an iRule. And there's DevCentral. DevCentral actually has you go to the co-share and you can actually go to DNS and it'll list all of the common DNS iRules. Pass it over to Greg.
You hear me? All right, cool. Thank you. Thank you, Dave. So AFM protections for DNS. So there's really 3 layers here that you want to focus on. The first one is going to be a DOS profile. And what that is, it's essentially a configuration of the thresholds on the vectors that the big IP can detect on that get applied directly to a virtual server. This is actually really helpful for kind of managing on a per app basis what the policies are. Back in host have different capabilities, and your DNS server will have different levels of thresholds and different features in the big IP AFM, which you'll see here, that can be applied at the VS level. The second one is the device configuration. So that's more about protecting the actual box itself and the network around it, and that's just going to apply to all traffic that's going in and out of the box. And then the last thing we'll get to is the DNS profile security, or the protocol security. So the first one, the flood and denial of service protections. Again, configurable at the device and at the virtual server level using the policies, layer 2 to layer 7 protections, including DNS. So there is the DNS specific attack vectors that are included. Automatic thresholds for detection and mitigation. So that basically uses, the big IP uses machine learning to come up with its own baseline of what normal traffic looks like for you. And then if there's a burst of traffic past a certain point, it will consider that an attack. However, if it steadily increases, it's aware that load can go up and down. So you don't have to keep constantly coming back and tweaking your numbers. But in this example, we have it set up fully manual. So we're specifying a detection threshold. Who has AFM in their environment today? Has anyone bought it and hasn't deployed it yet? Or just has it kind of turned off? So if you have it, you can go into these signatures today and at least go into detection mode. So if you want to get an idea of what your DNS traffic looks like, or if you're having the attacks that you're just not aware of yet, at the time, you set the detection thresholds on, and set the mitigation to infinite, and start getting some data before you go and implement the protections. And then we have the bad actor detection. That's going to plug into the IP intelligence. Essentially, we're going to classify a source IP when the vector is triggered. We're going to classify it as a denial of service host in IP intelligence. And even without the IP intelligence subscription, you can still take advantage of the categories and create a policy that just says, anybody who's on the bad actor list, just shun the connections. That way, you're dropping the traffic before at the hardware level before any further processing goes on. And then external BGP advertisement. So we can do remote trigger black holing. So you can advertise the attack IPs northbound and black hole it at the perimeter router. So these are the DNS and DOS flood vectors that are available. These are the DNS specific ones. So there's other ones like TCP/SYN that are in the generic vector section. When you go into the big IP to configure, there's actually a DNS security section which brings up these queries. So you can check on the ones that you want to mitigate against, and then go in and set your values for detection and alerting. You really want to, if you're going to deploy this in the real world, you really want to at least go into detect mode first, or do some load testing on your DNS servers internally or in a sandbox, and get an idea for what your DNS infrastructure can handle. Or better yet, use DNS Express and really jack that number up. So this is security profiles. This is it's a protocol firewall, if you will. So what you can do here is create a list of request types, query types, and put them in a category, and then set it as inclusion or exclusion. So you can either say only allow these or block these specific requests. But there's a lot of DNS request types that really aren't being used for anything anything good. And a lot of request types, like maybe MX, like maybe your DNS environment doesn't support that. Maybe your mail is outsourced or something like that. So if you don't have a reason to answer those types of requests, you can just block them using this functionality. And this is a DNS security profile that gets attached to the LTM DNS profile. So when you're creating your virtual server, you would see in the DNS profile section, you'd be able to choose this as an option. Inspection profiles, so available in 13.1, and we're building this base. These are IPS signatures, so these are really like top DNS attack signatures that you can enable. So the F5 can detect and drop traffic based on unknown attack signatures. We'll kind of go into IP intelligence. So the way that works is that the big IP has a list of categories. Everything from, it could be spam, it could be denial of service host. And what you're doing is you're applying that policy that says when I see traffic that matches one of these groups by IP address, this is the action I'm going to take. So for example, denial of service, we could shun those users. In IP intelligence, you can actually subscribe to a subscription that's centrally managed. So when attacks launch in the real world, those IPs get pushed down to your big IP, and you're blocking well-known and attacks in the wild. And that list gets updated every 5 minutes. So if a big attack does jump off, it's not a daily or a weekly update. I mean, it's pretty constant. Yes, sir.
When you say updated every 5 minutes, you mean the big IP has to query it every 5 minutes? Or is that just different?
That's so often the reputation list is updated. So you're welcome to do it every 5 minutes or 10 or 15, depending on. You can modify that threshold. And then again, that prevents bot command center. So as bots pop up and get detected, they get put in the database. And finally, analysis. So the big IP gives you a lot of information on your DNS infrastructure. So you're going to get reports on how much traffic has come in that's DNS specific. I know it's kind of hard to see because the projector's off the screen, but you can actually get a breakdown of query types and query counts. And then again, DNS Express, performance statistics, and so on and so on. And then this is AVR, so you can get these really pretty graphs that'll show you everything from top queries, top query types, top domain names, attacks. What attacks have you seen over the last 24 hours or several days, and really get some good, useful, actionable information out of that.
Yeah, actually, how many of you are using the AVR? Oh, actually, quite a few in this one.
Yeah, that's good.
So another nice thing about this is, at a glance, I can see what's going on here, and I can see, well, look at this. This is the query name that's got the most hits. I can actually click into that and then drill down into it, and it'll show all the clients that have requested that fully qualified domain name. And from there, I can also click into the client's address and keep drilling down until I can find out, what's actually going on. Where is this? Is it one client that's doing, maybe has some malicious software, or is got a virus or something like that? And it makes it very easy to figure out what's going on in your DNS infrastructure, and if there's an issue to correct it very quickly. From the clients. Well, it depends. So, right, if you're looking, are you using us as a resolver? So resolver in a cache, or are you using DNS Express, or are you using GSLB? Yeah, so with GSLB, unless you have EDNS 0 on, you'll just see the LDNS, right?
But you're still not seeing that, right? Because, right, that's the ECS which is what happened. There's only two public versus resolvers that support it.
Support what?
ECS. DNS client.
There's actually quite a few that support that.
But you guys don't have that ability to.
We do, actually, in 14.0, which was just released. In 14.0, we released EDNS 0 client subnet.
Exciting
So
stuff.
in that case, you would see the actual client's IP address.
Also, BigIQ 6.0.1 was released, I believe, last week. And the DNS reporting in there is beautiful now. It's come a long way since even the 5.4 version. And if you have a lot of GTMs or DNS, BigIP DNS deployed, or you want just a central management for all that, not only can you really manage the whole configuration, but you're getting really detailed reporting in BigIQ now. So BigIQ 6.01, if you haven't looked at BigIQ in a while, I would definitely ask your SC for an eval and spin it up and check it out. The DNS visibility is really top notch. We have a large SP customer actually right now that we're doing a POC with on this, and they gave us a lot of requirements, and we're quickly deploying the functionality that they're asking for. So the DNS specific tools inside of BigIQ are being released and being developed actively. So it's there's a lot of exciting stuff out now in 6.01, and then a lot of new stuff's coming soon.
Yeah, one of the roadblocks to using BigIQ for DNS was the fact that you did have to have AVR turned on, and you have to do the query logging, which it used to be much more resource intensive. I think at one point a while back it was like 50% utilization of your resources if you were using AVR. But they've done a lot of performance enhancers to AVR, so I believe it's 15 to 20% CPU hit for AVR, and that's all the information that AVR collects goes to BigIQ, and so you'll see all that information.
Cool, Dave. You want to take over the last few slides here?
So we'll go over some problems and solutions. So greater threats and volume loads on DNS infrastructure. If you look at it, just the DNS traffic, a while back you load a home page, and it was probably some static text with maybe a picture or two all on a page. So very few DNS requests. You look at it nowadays, you go to CNN.com or some of these other places, and just to load the home page is over 100 DNS requests in order to load everything with all the pictures and the links and all that kind of stuff. And the problem with that is you can have the fastest web server on the planet, but if your DNS infrastructure is slow, it's going to be slow. It's going to be a bad experience for your customers. So the current solution is to buy more DNS servers to handle the volume. You know, a lot of times they'll throw an LTM in front of a pool of DNS servers. The best way to mitigate any DDoS attack is to simply be able to have the performance in order to handle that, and that's what we do. We have the best performance on the planet. And of course, app and site outages are very expensive, and people are learning that if they attack a web server, they may take down the web server, but if they attack DNS, they can take down everything. All digital communication starts, you know, with a DNS request. So this current solution, you can route it to DNS scrubbers, and we actually have our own scrubber out there, Silverline. And also, enterprises desire to block users to access IP with malware and viruses. Some vendors do offer DNS firewall, but one list, no access to the database. We're vendor agnostic. We allow you to use whichever feed you'd like to, and you can also create your own if you don't want to pay for it, or if you're required by your government to run their specific RPC, we allow that as well. So intelligent DNS and global app management, scale managed DNS and apps globally. You improve application performance and availability. That's probably one of the biggest takeaways is the performance. And you need that performance, especially in today's market, because if a client's coming to you and your website's slow, it won't take them long to find somewhere else to go. You also want a robust, flexible, and secure DNS infrastructure. And you'd like to easily mitigate DNS attacks with complete DNS security and support hybrid IP environments. So you can set stuff up locally, or we can set up in the cloud, and you can also push your policies, whatever they may be, whether you're using DNS Sec or anything else, and you can push those policies out, whether it be to one of the clouds or even a private cloud. And for more information, I put the link for Big IP DNS, formerly known as GTM. Any questions?
I believe AFM is in the best license, right?
It is in the best license.
Is it in the better license?
It is also in the better license. As a matter of fact, when you buy better, you're generally either buying it for LTM and GTM or DNS together, or you're buying it for DNS and AFM together.
Okay. He was taking the question of how many people are licensed.
Right, because a lot of people will buy the best, and you know the best or the better includes LTM, DNS, and AFM. So you may have bought a better license and didn't know you had AFM, or you hadn't provisioned, because you do need to go in and provision it. Even if you have the license for it, you have to provision it as well. Yes. So DNS over TLS is actually a pretty new topic for me, anyways. Even though you know my whole day is spent doing DNS stuff, and it's actually kind of funny because when it was first brought up, I was talking to my manager at the time, and he's like, "Oh, what about this? You think we should support this?" I'm like, "Well, I don't know. I mean, it seems to me like the only reason you would use DNS over TLS is you want to hide what you're doing. So you want to hide it from your service provider. You want to hide it from everybody. So I'm like, I don't know that it has that much of a purpose. But then when I was out at the DNS symposium a couple weeks ago, we had a speaker come on and talk about that, and it actually is going to replace DNSSEC, or could replace DNSSEC. It has all of the securities of DNSSEC, but doesn't have the drawbacks, right? You don't have to validate it. You don't have to worry about spoofing. You don't have to worry about any of that kind of stuff. It is a little more resource intensive because it's TCP, of course, and not UDP. However, if you have hardware acceleration like we do, it doesn't really affect it all that much. So we actually, if you go on Dev Central, you'll find a solution for that. We already support it. And basically what we do is we actually set up a LTM virtual server, and we put SSL on it on port 853. And so when the client comes through, we terminate that SSL, we send it back to the DNS server, gets an answer, brings it back, re-encapsulate it, and send it back. However, we are looking at productizing it so it'll actually eventually be a checkbox in the DNS profile and be able to do it right there. The client does have to support it, yes. The LDNS has to support it as well. So I think right now there's only a handful. I think Cloud9 is one of them that does. Cloudflare, I believe, does. But yeah, if you Google that, you'll see there's actually a few that are already supporting that. And as far as I think Android, the client is actually going to support that. Does support it or will support it shortly. EDNS 0. So EDNS 0 is actually, it's just an extension for DNS. And depending on the option code, you can pretty much do with it what you want. Option code 8 is the client subnet. And what that does is when you have that option enabled, it will actually pull the client's IP address and stick it in there so that you can see not only the LDNS's address, but you'll also see the client's address. I believe only goes to a /24 though, so it's not the exact address. It's a range. Pardon?
14 for that.
For EDNS 0 is 14, yes.
So these iRules that the clients have used?
No, we don't use. We can now. I mean, we can currently do it on any version with an IP address, or with an iRule. However, it's productized in 14.0, so it's a checkbox if you'd like to use it. And then you can use it with your topology records, the GeoIP location stuff, all the good stuff.
So it's been already released, right?
Yeah, so it's released.
What about Cloudflare's DNS of HTTPS, the new protocol?
Yeah, that's DNS over TLS, same thing, HTTPS or TLS, yeah. Yep.
Good deal. Any other questions? Cool. Thank you very much, everyone.
Thank you.